Hi folks, we're still trying to explain why are black holes black? Right? Why are black holes black? Well, we talked a little about orbit and orbit being a state of free fall. But there's another mathematical property of every object, and that is its escape velocity. Escape velocity is basically how fast an object has to be going so that it can escape from the planet or moon or asteroid. Here's how this works. Back to our cannon on a high hill. If I'm going a little bit fast, it'll fall. A little bit faster, it'll go further before it falls. Fast enough, if I throw it sideways fast enough, it will orbit the entire planet. But there has to be a special speed, really fast speed, that you have to throw an object so that it won't get trapped by the planet's gravity and pulled back around. So fast that once it's shot out, the force of gravity is not big enough for it to curl back in and come into orbit. And that speed is called escape velocity. Near the surface of the Earth, that is about 25,000 miles per hour. Now, that is really nutty fast. I mean, that is crazy nutty fast. That's going around the Earth more than once, that's orbiting more than once per hour. That's pretty quick. But still, this is not hard to do if you're talking about small objects, space probes, things of that nature. Why? Force is mass times acceleration. This is Newton's second law. And here's what this means. If you want to accelerate an object to a really big speed, A, acceleration, and the object has a very small amount of mass, so you're talking about a probe you're sending to Jupiter or Mars or Saturn, the amount of force you need is calculatable, okay? The challenge is if you want to throw something very large, heavy, or massive, and you want it to escape from Earth's gravity, the force you have to give it has to be bigger. So if you again have to accelerate it really big, but the mass of the object is really large, the force needed to make that object move that quick is going to be nutty big. NASA is working on future missions to Mars. And when we send astronauts to Mars, we are going to have to send a lot of physical stuff with them. It's going to be at least a 6-month journey where they're going to need water, they're going to need food, they're going to need air, and they're going to need the mechanism and the fuel in order to come home again. So what we're going to send to Mars is going to be a larger payload than anything we have ever launched into space. Because of that, NASA is working on, and they are currently testing, Orion rockets. This is a picture of an Orion rocket test, and these rockets are probably, at this moment in history, the most technologically advanced thing mankind has ever made. And these rockets are so powerful that we will be able to launch these massive payloads with enough speed so that they can escape from Earth's gravity, and we have a shot at going to another planet. Now, the mathematical equation for escape velocity is this. The escape velocity to escape any planetary body is the square root of the number 2 times g. G is a constant. It's called the universal gravitation constant. M is the mass of the planet or sun or star or moon that you're trying to get away from. And R is the radius. And you can calculate how fast an object has to be going in order to escape from any object if you know its mass of the Earth, Moon, Sun, etc., and the radius. How far away from the center are you starting? If you want escape velocity, if you wanted to escape from the sun's gravity at the distance we are from the sun, so here's the sun, here's the Earth out here. If we wanted to launch something like Voyager spacecraft that's been out in the solar system for over 30, 40 years or so, how fast did it have to be going? nutty crazy fast, almost 100,000 miles per hour. That is insanely quick. Why were we able to do it? It's very, very tiny, very, very small mass, so we could give it a large acceleration with the rocket engines that we had, but it's because it's a very tiny ship that we're launching. If you were as close as the sun and you wanted to launch a probe fast enough to actually escape from the sun's gravity, it would have to be going well over 1 million miles per hour. So that is incredibly fast, or 0.2% of the speed of light, which is nutty crazy fast. So what does all of this have to do with black holes? A black hole is the remnant of a dead star. And you have something that has, now to start out, to become a black hole, the star has to begin with 10 to 100 times the mass of our sun. That's before it goes supernova. If after the supernova explosion you have 2 or 3 solar masses left over, it possibly can become a black hole. So I picked some numbers out of the air. Let's say I've got something that has 3 times the mass of our sun. And we pack it very, very, very tight into a radius of about 1 kilometer. Okay, 1 kilometer is about 0.6 miles, not a little bit bigger than half a mile. If we did that, the escape velocity from that black hole would be 90 times 10 to the 8th meters per second, or 30 times the speed of light. And as far as we understand physics at this moment in history, is that the speed of light is the speed limit of the universe. We cannot have anything that travels faster than the speed of light. It is the fastest speed possible. So black holes are black because they are so massive and have a small enough radius that their escape velocity is actually larger than the speed of light. And what that means is that light cannot escape, and hence the black holes are black. Now, according to Sir Isaac Newton, good old Isaac Newton, back in the 1600s, trying to explain black holes, nobody thought about them back in the 1600s, but using the laws that Newton established back then, we come to the conclusion that nothing can escape from a black hole. No light. When we say light, that also includes no radio waves, no information of any sort. So anything that falls into a black hole is gone, cannot ever be retrieved. We can't see any signals from it. We cannot get any information from the inside of a black hole. And if any matter, any little molecule that falls in, or person or spacecraft or piece of dust that falls in, it cannot ever get out because gravity is so extreme. The other thing is, because the gravitational force is so extreme, even if you have a tiny little particle like a proton, and you use Einstein's equation E equals mc squared, and all of the mass of the proton gets converted into energy, it still will not have enough energy to get out. So basically, nothing can escape from a black hole. All right, that will do for this one. When we come back, we're going to talk about general relativity, very weird and very cool stuff.